Unit 2, Lesson 2, Part 2. We're now going to look at some alternate forms of the derivative and how they can be used. The first one are the numeric forms of the derivative. So this is if we are finding the derivative at a specific point and only that point. So the answer is going to be a number. It's not going to be a function. So we've used this before. So f prime of a, which is the slope of our tangent line, is the limit as h approaches 0 of f of a plus h minus f of a over h. Or if you want to use a form that's more aligned with our typical slope formula, like a y2 minus y1 kind of thing, we have f prime of a equals the limit at x approaches a of f of x minus f of a over x minus a. And of course, these only work if the limits exist, and they only work for a's where the limit exists. Okay, so let's use the alternate form of the derivative to find f of a prime for f of x equal to 3 times the square root of 3x plus 1 at x equals a. So I am going to use this form. The limit as x approaches 1 of f of x minus f of 1 over x minus 1. So I need to know what f of 1 is. So I'm going to do that over here. So f of 1 is going to be the square root of 3 times 1 plus 1. So I get the square root of 4, which is 2. Okay. So I'm going to have the limit as x approaches 1 of my function, square root of 3x plus 1, minus my value of my function at a, so that's minus 2, all over x minus 1. So now I have to simplify this, so I'm going to do that by using the conjugate. So I'm going to multiply top and bottom by the square root of 3x plus 1 plus 2 over the square root of 3x plus 1 plus 2. So I now have the limit as x approaches 1 of 3x plus 1 minus 4 over, in parentheses, x minus 1 times my conjugate, so the square root of 3x plus 1 plus 2. Okay, when I simplify this then, the idea is using the alternate form that undefined term in the denominator, the x minus 1, is going to be able to be factored out if the derivative exists, which is going to happen here. Hopefully you can see that I do have a factor of x minus 1 in the numerator. So a factor out of 3. So the limit as x approaches 1 of 3 times x minus 1 over x minus 1 times the square root of 3x plus 1 plus 2. Those will cancel. So I'm taking the limit as x approaches 1 of 3 over square root of 3x plus 1 plus 2. Now I can direct substitute. So this is going to be 3 over the square root of 3 plus 1 and then plus 2. So f prime of 1 is going to equal 3 over 4. Okay. Observations. When finding a derivative of a point, there are two approaches. You can either find the general formula that will work for any point that the derivative exists and substitute your x value, or you can substitute your x value first and do the derivative that way. So, some things to keep in mind is if you're given one point and you're looking for the derivative, you're finding the instantaneous rate of change at that specific point. It's also the slope of the tangent line. The slope of the tangent line is also the derivative at that point, and it can be found by using the difference quotient. If you're given 2 points, now you're only finding the average rate of change over that interval, and that becomes the slope of the secant line and you're really just using the slope formula to find that value. So I want to make sure that you understand that there is a huge difference between being given 1 point and 2 point. Okay, so now let's estimate a derivative of a point. Let's say we have a hyperbola, and we want to find the slope of the tangent line at x equals 3. So our hyperbola equation is 2 over x. So we're just going to use this limit definition, which is one of the alternate definitions. So what we're saying here is that our a equals 3. So I'm going to first find what f of 3 is. So f of 3 is going to be 2/3. So now I can find my slope. So m is going to equal the limit as x approaches 3 of my f of x, which is 2 over x, minus my 2/3, my f of a, all over x minus 3. Okay, so I'm going to take the limit as x approaches 3 of, I'm going to make a common denominator here, so I get 6 minus 2x over 3x, and this is all over x minus 3. Simplifying that fraction, I get the limit as x approaches 3 of 6 minus 2x over 3x times x minus 3. And again, if this derivative exists, I should be able to have a factor of x minus 3 in the numerator. So I am going to factor out a -2. So I'll be left with x minus 3 over 3x times x minus 3. These will cancel. So I'm taking the limit as x approaches 3 of -2 over 3 over x. I can now direct substitute, and I get -2/9. So my slope of the hyperbola at x equals 3 is -2/9. Okay, so now let's do it using the definition of the derivative. So it's going to be a little different. So now that I'm finding my m in this way, m is going to equal the limit as h approaches 0. F of x plus a is going to look like this, 2 over 3 plus h, minus f of a, that's still 2/3 that we found in part A, and that's all over h. So again, I'm going to make a common denominator in the numerator so I can simplify the fraction. So I'm taking the limit as h approaches 0 of, let's see, 6 minus 2 times 3 plus h, and this is all over 3 times 3 plus h, and this whole thing is over h. So simplifying this, so we have a limit as h approaches 0. The 6's will cancel, so I'm left with -2h on the top, and the bottom becomes 3h times 3 plus h. h's cancel, so I'm taking the limit as h approaches 0 of -2 over 3 times 3 plus h. I can now direct substitute, so I get -2 over 3 times 3 plus 0. So my slope is, again, -2/9, just like it was in the first part. Okay, so just remember, all these things mean the same thing. I'm kind of like hitting a dead horse here, but I want to make sure that we're clear because all these terminologies could come up in the test. You're looking for the slope of the tangent line of f at x equals a, the instantaneous rate of change at x equals a, the derivative at x equals a, or the limit of the difference quotient. Any of those terminologies could come up. Okay, I'm going to stop here, and I am going to finish the notes in a third video, so this video isn't too long.